Hello friends, this is J. Annie Mary Lima, Assistant Professor of Mathematics, Holy Cross College Autonomous, Nagarkoil. In this video, we are going to see about continuity and discontinuity of a function. First, let's see the definition of a continuous function. A function is continuous at a fixed point if we can draw the graph of the function around that point without lifting the pen from the plane of the paper. That is, a function is said to be continuous at x is equal to a if there is no interruption in the graph of f of x at a. Its graph is unbroken at a and there is no hole, jump or any gap. Mathematically, a function is said to be continuous at a point x is equal to a if the following three conditions are satisfied. Number 1. F of x is defined, that is, it exists at x is equal to a. Number 2. The limit of f of x as x approaches a exists. Number 3. The limit of f of x as x approaches a is equal to f of a. A function f is continuous on an interval if it is continuous at every point in the interval. Next, let's see an example of a continuous function. In this figure, the graph of the function f of x is given. The function f of x in the given figure travels from x is equal to 0 to x is equal to 3 without any interruption. And since the two endpoints are closed, which are designated by the filled in black circles, f of x is continuous on the closed interval 0, 3. There are common types of continuous functions. The following functions are continuous on every interval inside their domains. Polynomials for all x. For example, y is equal to mx plus b, y is equal to ax square plus bx plus c. Rational functions except at points x, which gives division by 0. Root functions nth root of x for all x if n is odd and for x greater than or equal to 0 if n is even. Trigonometric functions, inverse trigonometric functions, exponential functions and logarithmic functions. Next, let's see the definition of a discontinuous function. A function f of x is said to be discontinuous at a point a of its domain D if it is not continuous there. The point A is then called a point of discontinuity of the function. In the case of discontinuity of a function, any one of the following three cases may arise. Number 1. The right hand limit or the left hand limit or both of a function may not exist. Number 2. The right hand limit and the left hand limit of a function may exist but are unequal. Number 3. The right hand limit as well as the left hand limit of a function may exist but either of the two or both may not be equal to f of a. Next, let's see the types of discontinuities. First one, jump discontinuity. Second one, infinite discontinuity. Third one, removable discontinuity. This figure shows all the three types of discontinuities. First one is the vertical asymptote or infinite discontinuity. Here, the function goes off to infinity. Next is the jump discontinuity. Here, the function jumps from one value to another value. Third one is whole or replaceable discontinuity or removable discontinuity. Here, limit extends to a, f of x exists, but it is not equal to f of a. So this discontinuity can be removed. Now let's see the discontinuities one by one. First is the jump discontinuity. Jump discontinuity is of two types. First one, continuity of the first kind. In this jump discontinuity, the left hand limit and the right hand limit exist and are finite but not equal to each other. Next one is discontinuity of the second kind. A function f of x is said to have discontinuity of the second kind at x is equal to a if neither left hand limit of f of x at x is equal to a nor right hand limit of f of x at x is equal to a exist. In this figure, the function f of x is defined by f of x is equal to 1 when x is less than or equal to 0, x when x is strictly greater than 0. And the function jumps from the value 1 to the value x. Next, let's see infinite discontinuity. In infinite discontinuity, the function diverges at x is equal to a to give a discontinuous nature. It means that the function f of a is not defined. Since the value of the function at x is equal to a does not approach any finite value or tends to infinity, the limit of a function as x tends to a are also not defined. In this figure, the graph of the function y is equal to 1 by x is given. As x approaches to 0, the function goes off to infinity. So this function has infinite discontinuity. Next is the removable discontinuity. A function f of x is said to have a removable discontinuity at x is equal to a if left hand limit at x tends to point a is equal to the right hand limit at x tends to point a, but their common value is not equal to f of a. A removable discontinuity occurs when there is a rational expression with common factors in the numerator and denominator. Since these factors can be cancelled, the discontinuity is removed. In this figure, the graph of the function f of x is equal to x plus 3 by x square plus x minus 6 is given, and this function has a removable discontinuity at the point minus 3, minus 1 by 5. Thank you.